Greetings, pre-calculus students, to another lesson in our unit on trig and the unit circle. We have one more, I guess you could say, type of problem we're going to recap or we're going to review before moving on to another aspect of our unit. And it's the following. We're going to evaluate trig functions determined by a point on a circle and an angle in standard position. And then we are going to use a trig ratio with restrictions to find the others. Now, you'll see that the problems that we're about to do in today's lesson are going to be very similar to the problem that you completed in today's bell ringer. But in a sense, it's going to tie in some of the things that we've been doing with the unit circle in terms of constructing a triangle inside a circle and then identifying what each of the trig functions are equal to, so on and so forth. So let's get to it. Before that, let's quickly review the quadrants. Now, we reviewed the quadrants in class one day, but we're going to quickly review them today as well. So remember, there are 4 quadrants in the XY coordinate plane. Okay, there's quadrant 1, which is in the top right. There is quadrant 2, which is in the top left, quadrant 3, which is in the bottom left, and quadrant 4, which is in the bottom right. So you'll see the way it moves, 1, 2, 3, 4, is that it moves counterclockwise, much in the same way we've always moved counterclockwise around the unit circle. So we're gonna do a quick recap for each of these questions using these quadrants. So let's see, sine of theta is positive in which quadrants? So sine of theta is positive in which quadrants? Well, we know that sine of theta, at least in terms of the unit circle, sine of theta is equal to y, right? In terms of the unit circle, sine of theta is equal to y. So, in other words, this question is asking, when is the y value positive? In which quadrants is the y value is positive? Well, I like to think that you would agree that the y value is positive whenever it is above the x-axis. Whenever a point is above the x-axis, your y value will be positive. Well, the 2 quadrants that are above the x-axis, let's see, I think I can use a laser. Yeah, there we go. The 2 quadrants that are above the x-axis are quadrant 1 and quadrant 2. So those are the 2 quadrants in which sine of theta will be positive. Now, what about the next question? When is cosine of theta negative? Well, we know cosine of theta, at least when talking about the unit circle, which is also on a xy coordinate grid, cosine of theta is equal to the x value of the point on the unit circle. So in other words, when is the x value of a point negative? Well, the x value of a point is negative whenever you have a point to the left of the y-axis, right? So to the left of the y-axis, all your x values are going to be negative for your points. Hence, that's going to happen in quadrant 2 and quadrant 3. You do see that I'm using Roman numerals for these quadrants, and typically when talking about the quadrants, the Roman numerals are used 1, 2, 3, 4 as opposed to regular numbers. Tangent of theta, now this one might be a little bit trickier. We know that tangent of theta is equal to y over x. We do know that. So let's think about this. So you're dividing 2 numbers, in other words. You have y divided by x. Well, in order to have a positive result, right, in order for your result to be positive from y divided by x, either both y and x are positive numbers or y and x are both negative numbers, right? Because if you divide 2 negative numbers, you get a positive. If you divide 2 positive numbers, you get a positive. Well, let's think about it. Where are both x and y positive? Let's start there. Well, x and y are positive in the top right of your coordinate grid or in the first quadrant. So we got that. Well, where are y and x both negative at the same time? Where the only place that happens is going to be in the bottom left of the xy coordinate plane. So that means quadrant 3. Okay? So that's just a quick recap. And these types of questions are questions that you'll see in a future problem in today's lesson are important to be able to answer. So let's get to our first example for today. So evaluating trig functions determined by a point on a circle. Now you'll see this time I did not say the unit circle, and that's intentional because the circle that this point will be located on is not going to be on the unit circle. It's going to be on a circle centered at the origin 0, 0, but it's not going to be a unit circle, all right? So the point 5, 3 is on a circle that is centered at 0, 0. So let's draw a picture of this. All right? So we have a circle that is centered at 0, 0, and then we have a point on it at 5, 3. So, it doesn't really matter exactly. I'm just eyeballing it here. So let's just say 5, 3 is about there. Okay, so that's 5, 3. Now remember, what does that mean? Well, remember, we can still draw a triangle, much in the same way we drew triangles back when we were doing the unit circle that could represent this point. Okay? And actually, let me finish the question. Let theta be the angle whose terminal side contains the point. Okay? So all this is saying is that we have an angle, okay? And the terminal side is that blue line that I drew going from the origin to the edge. That's the terminal side of the angle. That's all it's saying. And then it says, find the 6 trigonometric functions for theta. Okay? So if you recall, the way we drew a triangle from this point is we basically drew a vertical line extending down. Okay, we drew a vertical line extending down that gave us a right triangle. Now, since this is not a unit circle, once again, this is not a unit circle, we do not know the hypotenuse of this triangle. Okay, we do not know the hypotenuse of the triangle. We knew the hypotenuse of this triangle when it was a unit circle because we knew the radius is 1. The radius was 1. In this case, we do not know that the radius of 1 is 1 of this triangle. It actually isn't 1, as you'll see in a second. But we do know the point is 5, 3. Well, there is something that we do know. We know that, remember, a point consists of an x value and a y value. Well, remember, an x value represents a horizontal distance or horizontal movement in the xy coordinate plane, which in this case would represent the horizontal side of the triangle. So that in this case will give us that would be our 5. Okay, so the length of that side of the triangle is 5. Conversely, we know that y represents a vertical distance or vertical movement on the xy coordinate plane. So that makes that side of the triangle 3. So we do know that, okay? We know that the bottom side of the triangle is 5 and then the vertical side is 3. Well, we've done this before, and you just did this in the bell ringer. How do you find the third side of a right triangle if you know 2 sides? Pythagorean theorem. So that's what we're going to do. We're going to use the Pythagorean theorem to determine what the hypotenuse of that triangle is. So let's do that. So Pythagorean theorem, so we have 5 squared plus 3 squared is equal to c squared. Don't forget, people, c is always your hypotenuse. So in this case, since we do not know the hypotenuse, that is what we are trying to solve for. So we're trying to solve for what c is equal to. So we have 25 plus 9 is equal to c squared. So 34 is equal to c squared. We square root both sides to get rid of the squared. So that means c is equal to the square root of 34. So that's the hypotenuse. The hypotenuse is square root of 34. Okay? Because we're asked to find we're asked to find all 6 trigonometric functions. Okay, so we're going to solve for all 6 sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, and cotangent of theta. Okay? Now for this one, you're going to have to remember your trig ratios just like you did in the bell ringer. Okay, you're going to have to remember your trig ratio. So we covered the fact that in the bell ringer, sine of theta is equal to the opposite over hypotenuse. So in this case, if we look at our diagram, we already know that the square root of 34 is our hypotenuse. The 5 would be the adjacent because it is the side right next to the angle, and the 3 would be the opposite side. Okay, so sine of theta is opposite over hypotenuse, giving us 3 over square root of 34, and you can just leave it like that this time around. No need to get rid of the square root in the denominator like we've had in the past. So you just leave it as 3 divided by the square root of 34. Cosine, on the other hand, is adjacent over hypotenuse, giving us 5 over the square root of 34. Tangent of theta is equal to opposite over adjacent. Opposite over adjacent, which would lead us to 3 over 5. And then we do the reciprocal functions. Cosecant is the reciprocal of sine, which would lead us to hypotenuse over opposite, which in this case would be square root of 34 over 3. Secant is the reciprocal of cosine, hypotenuse over adjacent, which would give us square root of 34 over 5. And then finally, cotangent is adjacent over opposite, giving us 5 over 3. So very similar to the problem that you did in the bell ring. Okay, very similar to the problem you did in the bell ringer, except this time around, we're talking about a, we're talking about a point on a circle, and then using that information to construct a triangle, which would lead us to the other, which will lead us to the 6 trig ratios from there. All right. So now let's do another example where it's not in quadrant 1, because if you notice with this one, this point was in quadrant 1. Okay, this point was in quadrant 1. So let's see what happens to our next point. So example 2. The point -4, 2 is on a circle that is centered at 0, 0. Let theta be the angle whose terminal side contains this point. Find the 6 trigonometric functions for theta. Okay, so let's draw our little circle. Okay, we got our circle here. We have a point at -4, 2. So -4, 2. So I don't know, it's probably like somewhere here, right? Who knows? Okay, and we could draw our little triangle, right? We can draw our triangle. So our theta this time around is actually this. Okay, that's our theta, because remember, we're always, on these circles, we've always been measuring our angles counterclockwise from the positive side of the x-axis. So that does not change here. We're still measuring it the same way. So we got that down, all right? And we can construct our little triangle, or right triangle, sorry, by drawing a vertical line down. Okay, so you have your little right triangle. Okay, so now let's see. So once again, the point is -4, 2. The point is -4, 2, which would indicate to us that the horizontal side of this right triangle is -4, quote unquote, -4, and this vertical side is 2. Now, it might seem weird to you to see a side that's -4. But you have to think about it, it's -4 just in the context of where it is on the circle. Okay, it's -4 in the context of that's where it is on the circle. So just keep that in mind as we're moving forward through this. So let's find that hypotenuse. Let us find that hypotenuse by doing the Pythagorean theorem. Okay, so -4 squared plus 2 squared is equal to c squared, because once again, c is always the hypotenuse. In this case, we don't know what the hypotenuse is equal to. So we got 16 plus 4 is equal to c squared. 20 is equal to c squared. We solve for c by taking the square root of both sides, and this leads us to c, the hypotenuse, being the square root of 20. So square root of 20, there you go. Now let's do the 6 trig ratios, or 6 trig functions. So we have sine of theta, cosine of theta, tangent of theta, cosecant of theta, secant of theta, cotangent of theta. So let's see what we have here. So let's just label these really quickly. This is our hypotenuse, this is the adjacent side, and this is the opposite side. Okay? Because once again, adjacent side right next to the angle, opposite side opposite the angle, hypotenuse along the side of the right triangle. So sine, remember, is opposite over hypotenuse, just like we did in the previous problem. So this time around, we have 2 over the square root of 20. Cosine is adjacent over hypotenuse. So remember, we said the adjacent side was -4. So -4 over square root of 20. Tangent is opposite over adjacent. So 2 over -4, which you could simplify to -1/2. You know, no big deal there, -1/2. Cosecant, we end up with the reciprocal of sine. So square root of 20 over 2. Secant, we end up with the reciprocal of cosine. So square root of 20 over -4. And then cotangent, we end up with the reciprocal of tangent, so -4 over 2 or -2, right? 4 divided by -2 is -2. So those are our final answers for the 6 trig functions for theta, given the point on the circle, okay? So even if your point is not in the first quadrant, you'll see the process is basically the same, except this time, as you can see, one of our sides is negative. Okay, one of our sides is negative on our triangle, so that's something, obviously, that will reflect in our answers. All right. So now, example 3, you will be doing on your own. Okay, example 3, you will be doing on your own, and once again, submitting in addition to your notes. So obviously, you can just pause the video at this point, make sure you do your work. And then example 4, same thing. Okay, example 4 and example 3, you will be doing on your own. Basically the same process, except obviously this time around your point is going to be different, okay? So, you know, try drawing the point on the circle, drawing the little triangle, labeling the sides, going from there. Okay, there's one more type of problem I wanted to go over. And this time it's related to this idea of, all right, just like the bell ringer, right? What happens if we're given a trig function? So in this case, we're given cosine of theta, okay, and we're told to evaluate without using a calculator, using the exact values. So we're given that cosine of theta is equal to 2/3, and we're told tangent of theta is greater than 0. So what does that mean? So cosine of theta is equal to 2/3, and tangent of theta is greater than 0. Well, this is similar to the previous problems, but it's also similar to the bell ringer problem. And it's similar in the sense that we're going to use the information that's given to us to draw a triangle, but the information that's given to us is given to us in order for us to accurately identify in which quadrant is our angle actually found. In which quadrant is our angle actually found? Because let's think about this. So we're told that cosine is equal to positive 2/3, right? Excuse me. We're told that cosine is equal to positive 2/3. So cosine is positive. Well, what do we know? When is cosine positive? Well, cosine is positive whenever x is positive. Well, x is positive in which quadrants? Well, let's think about it. So x is positive to the right of the y-axis. So that happens in quadrants 1 and 4. If you were to go back a few slides and look at the grid, it would be positive in quadrants 1 and 4. Because that is when the x value is positive. Conversely, we're also told that tangent of theta is greater than 0. So when is tangent positive? Well, that's a question we actually already answered. We figured it out earlier that tangent is positive when y and x are both either positive or both negative. And that happens in quadrant 1 and quadrant 3. Well, what we're looking for now is where do these two facts overlap each other? Where do these both occur at the same time? Well, it looks like they both occur in quadrant 1. Hence, that is the quadrant in which we're going to be working in this problem. We're going to be working wherever these two values occur at the same time, which in this case is quadrant 1. That's the only place where both of these can be true at the same time. Quadrant 1 is the only place where cosine is positive and tangent is positive at the same time. Okay, that's the only place where that happens. Okay, in quadrant 4, cosine is positive, but tangent is not positive. And in quadrant 3, tangent is positive, but cosine is not positive. So you got to look at where both happen at the same time. So we know our triangle is going to be in quadrant 1, so let's draw it. Well, just a quick reminder, cosine is adjacent over hypotenuse, okay? Adjacent over hypotenuse. So that means in this case, our adjacent side is going to be 2 in our triangle, and our hypotenuse is going to be 3. So if we draw our little triangle in quadrant 1, so adjacent and the hypotenuse, so that is going to be, the adjacent is 2, and the hypotenuse is 3, since it's cosine. Okay? So we're asked to determine, well, what is sine and tangent? What is sine and tangent equal to? Okay, so sine and tangent. Well, once again, we know sine is opposite over hypotenuse, and we know tangent is opposite over adjacent. So we have a small issue here. We don't know what the opposite side is equal to. We do not know what the opposite side is equal to. But just like the bell ringer, and just like the previous problems we did, we can figure out what the opposite side is equal to using the Pythagorean theorem. So let's do that. So Pythagorean theorem. So, almost made a mistake. 2 squared plus b squared is equal to 3 squared. Okay? We know the hypotenuse this time, people. That's why we put the 3 where the c used to be. So let's see, we have 4 plus b squared is equal to 9. Subtract 4 from both sides. B squared is equal to 5. Take the square root of both sides to get the squared out of here. Oops. And we end up with b is equal to the square root of 5. So that means the opposite side is square root of 5. Okay, so the opposite side is square root of 5, so we can finish this up. So that means sine is equal to opposite square root of 5 over hypotenuse 3, and tangent is equal to opposite square root of 5 over adjacent 2. So that would be our final answer for sine and tangent, respectively. Okay? So once again, this information right here is there to help you determine which quadrant are you in. Which quadrant are you in? So be wary of that, because remember, depending on which quadrant you're in, you can have negative values for your sides. In this case, none of our sides are negative because we're in first quadrant and x, there everything's positive. But if you're in quadrant 2, for example, if you're in quadrant 2, that means the adjacent side would be negative at that point, because the adjacent side would be your x value, and then so on and so forth. So part B, I want you to do on your own. Okay, so part B, I want you to do on your own. Okay, so you're going to determine in which quadrant you're in first, and then from there determine what your cosine and cotangent are equal to, respectively. All right. So that is the end of today's lesson. So you have 3 on your own problems that you want to make sure you turn in addition to your notes. Otherwise, I hope this lesson went smoothly. As usual, if you do have any questions or concerns, just feel free to leave them. You can just leave a comment for me in the Google Classroom or whatever you feel most comfortable with. Otherwise, I hope you guys stay safe, and I hope you enjoy the rest of your